Hello guys, so in the last video of this playlist of JEE Concepts, we discussed the concepts of projectile motion, and in this video, by moving further ahead, we are going to discuss questions on this projectile motion. So let us move ahead. Now the first question is, like a football is kicked with a velocity of 20 meters per second at an angle of 45 degrees, like here. Suppose that the football is kicked at 20 meters per second. This is the value of u, and the angle theta is 45 degrees with the horizontal. Find the time taken by the ball to strike the ground. Like this is O, this is B, and this is A. So the question is asking the time of flight. That is the time taken by ball to reach the ground. Time of flight, as we already discussed, 2u sine theta by g. So just directly put the values. U is what? 20. Sine theta is sine 45 degrees upon g. G here we need to take 10, like this. So this is 4 sine 45, that is 1 upon root 2, which can also be written as root 2 root 2. This is 2 times 2 is 4, that is equal to 2 root 2 second. That is the answer to this A. The second one is, find the maximum height it reaches. That is this A. The maximum height is basically u square sine square theta upon 2g. That is equal to u square is 400 multiplied by sine square theta, that is 1 upon root 2 square sine 45 upon 20, because g is 20. That is equal to nothing but 400 upon 2 into 20, that is 20, and that is 10. So 10 meter is the maximum height that it reaches. The third question is, like, how far from the kick does it hit the ground? It means this OB. It is asking for the range. And what is the range? Range is u square sine 2 theta by g. That is the range. So u square is again 400 multiplied by sine 2 theta is sine 90. That is the maximum range. Maximum range occurs at theta is equal to 45 degrees upon g. G is 10. So this is nothing but 40, because sine 90 is 1. So 40 meter is basically the range. That is, at 40 meters from the kick, it will hit the ground again. That is, this OB is 40 meter. Now moving towards the next question. Well, a person standing on the top of a cliff 171 feet high has to throw a packet to his friend standing on the ground 228 feet horizontally away. So suppose that guy is standing over here. This is 171 feet and his friend is here, that is 228 feet. And this will be angle theta. So tan theta is equal to 171 upon 228. So from here, if you calculate, then magnitude wise theta will be equal to 37 degrees. Okay, this is 37 degrees. Now he is basically throwing the packet directly aiming at the friend with a speed of 15 feet per second. Like in this direction, the velocity is 15 feet per second. He is throwing. So this is theta, this is also going to be theta. So in the x direction, the speed will be u cos theta, and in the y direction, the speed will be u sin theta. So we are having u is equal to 15 feet per second. Small g is 32.2 feet per second square, and y is equal to minus of 171 feet, because we are taking this is positive y and this is positive x. That's why this is negative of y, that is negative of 171 feet. Now we need to find, like, how short will the packet fall. It means the packet is not reaching his friend at 228 feet. It will be something like this. It is taking something like this trajectory. It is falling short. So this is basically the range for this kind of throw. And we need to find this 228 feet minus of the range. This we need to find. That is what asked in the question, like, how short will the packet fall. So for getting this range, I am thinking of applying the equation of trajectory, which I have already derived in the previous video. Y is equal to x tan of theta minus of x square g sec square theta upon 2u square. This I have already derived. Okay, so putting all those values, like minus of 171 in place of y is equal to x multiplied by tan of theta. Tan of theta is 171 upon 228. But here one point to note is that this 171 feet is basically negative because we are taking y in positive direction, but the x, that is 228 feet, is positive. So this is positive, this is negative. So this tan theta is basically negative. So this theta is basically negative of 37 degrees, you can say. Okay, because y is negative but x is positive. So we have to write here minus 171 upon 228. Then minus x square small g multiplied by 1.568. This you can calculate. Like you already know tan theta value. So from there you can just get sec theta or any other values upon 2u square. Like 2 multiplied by 15 square is 225. So this will further reduce to 0.1125 x square plus of 0.7536 x minus of 171 is equal to 0. See, the concept is really important. Here now all the things is just doing the mathematics. Here the values is so much complicated, like 1.568, and even the unit is feet. So you have to take GS 32.2. So these things. So I'm directly doing it. Otherwise you can just take out the calculator and just find out all these things. So from here we will get like x is equals to 35.78 feet. Okay, this you can calculate with the help of calculator because this is basically somewhat complicated mathematical calculations. So this is basically the range covered by the packet. This is basically this one. If I'm saying this is OB, so this is basically the range of the packet, but we need to find this, like how short will the packet fall. So that will be 228 minus of whatever we get. What we get? 35.78. So 228 feet minus of 35.78 feet, and that is equal to nothing but 192 feet. That is approximately. This is how short the packet will fall. So this is the answer. Now moving towards the next question. So the next question is like, find the average velocity of a projectile between the instants it crosses half the maximum height. It is projected with a speed u at an angle theta with the horizontal. This is projected with u at an angle theta from the horizontal, that is angle of projection. And the question asks like find the average velocity of a projectile between the instants it crosses half the maximum height. This is the maximum height, which is h. Half of it, suppose this, and suppose this, like here. So this will be like h upon 2, maximum height upon 2, and this will be also like maximum h upon 2. So this will be something from here to here. Take this as A and take this as C, and the maximum height take as D. So it is asking for the average velocity when the particle is traveling from point A to point C, and the height is h upon 2, like this. So we know that average velocity is nothing but the displacement, like the total displacement upon total time. That is the average velocity. This is nothing but total displacement. Okay, total displacement upon total time. So from A to C, if you see, y is basically same. If you see in the y direction, then it is not having any difference between the heights of A and C, which means that is the displacement in the y direction is 0. So y direction displacement is basically 0, and we can say that average velocity in the y direction is basically 0 because the total displacement in the y direction is 0. So only one direction remains, that is the x direction, and we already know that in the x direction the velocity is u cos theta, which is nothing but constant because there is no acceleration in the x direction. And so because of this, the average velocity in the x direction is also going to be u cos theta because the velocity is constant. And so that is the answer to this question, that the average velocity in this case will be u cos theta, because in the y direction the average velocity is 0 because there is no displacement in the y direction. A and C are having the same elevation, but in the x direction the velocity is constant, that is u cos theta. That's why the average velocity of a projectile between the instants it crosses half the maximum height is u cos theta. That is the answer. Now moving towards the next question. The question is like, a staircase contains 3 steps, each 10 centimeter high and 20 centimeter wide. Each one is 10 centimeter high and 20 centimeter wide. What should be the minimum horizontal velocity of a ball rolling off the uppermost plane? This is the uppermost plane and this is the lowermost plane. So as to hit directly the lowest plane. Okay, we need this ball to hit directly the lowest plane, like this over here. So what should be the minimum horizontal velocity? That is VU minimum V02. This will also be 10, this is 20, and this will also be 10 like this. So this is a good question actually. You need to think something like this way in order to get the minimum velocity, that you need this ball to just reach over this point. Say this point be A. So you need this ball to just reach over to the point A, just touch this point A, and after that it will automatically comes at the lowest plane. So you don't need to throw the ball so that it just reaches this lowest plane, but you need the velocity for this ball to just reach this point A, just touch this point A. Then it will directly reach the lowermost plane. So for that the x will be like in the x direction, the range will be, this is x positive and this is y positive. So in the x direction the range will be this 20 plus 20, that is 40 centimeters, and y will be like this 10 plus this 10, 20, because we are only concerned up to here, this point A. So that will be minus of 20 centimeters because y is negative, because we are considering this y as positive. And theta will be 0 degrees. Why? Because we are throwing the ball horizontally at the uppermost plane. So for finding this minimum horizontal velocity, again just consider this equation of trajectory, that is y is equal to x tan theta minus of g x square upon 2u square cos square theta. Y is basically minus of 20, x is 40, tan 0, that is nothing but 0, sin 0 is 0, minus of g to x square is 40 square upon 2u square and cos square 0 degrees. So this is basically 0 because tan 0 is 0. And let us take g as 10 meters per second square. So meter you need to convert it into centimeter, because this is in centimeter, this is in centimeter. So 10 meter per second square means 1000, that is 10 multiplied by 100, that is 1000 centimeters per second square. So that will be equal to 1000 multiplied by 40 square upon 2u square cos square 0, and this is also 1 because cos of 0 is 1. So this from here we can write u square is equal to minus of 1000 multiplied by 40 square upon 2 multiplied by minus of 20. So this will be like plus, and this is like 1000 multiplied by 1600 upon 40. This cancelled out, this 4 times 4 is 16, 40. So we are total have 40,000 as u square. So from here u is what, 200 centimeters per second or 2 meters per second. That is the answer. So we need a minimum of 2 meters per second of velocity at the uppermost plane for this ball to roll just at the lowest plane. So that is the answer. So this is all about this video guys, and in the next video we will be taking some more questions. So till then, thank you.